Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In this session, we are going to study what is the laws of mechanics, engineering mechanics. There is various types of laws. One is the transmissibility of forces, another law is polygon law of forces, and rectangular law of forces. We are going to study the various resolution of the forces, various laws in engine mechanics which are useful for calculating uh, the resultant force. So let us give you a glimpse of what is engine mechanics. It is a branch of the science which deals with the which describes the conditions and predicts the conditions when the bodies are at rest or in motion. So, in briefly, there are three types of mechanics. One is mechanics of rigid bodies, and another one is mechanics of deformable bodies, and the third one is mechanics of fluids. So, the mechanics of fluids, in which we will study how the interactions of the fluids, such as the kinematics of the fluids, kinetics of the fluids, and dynamics of the fluids, fluid dynamics. So in the fluid dynamics again comes into the what is Darcy-Weisbach equation, Heisenberg's equation, etc. Now we'll consider here in engine mechanics or strength of materials. We'll assume that the bodies are rigid. What is the meaning of here? One more thing is that here when we are studying when the bodies are at rest, that is known as the statics, and the dynamics relates to the bodies which are in motion. So the mechanics of rigid bodies again divided into two parts. One is statics and the one is the dynamics. Now here statics, yesterday in the previous class we discussed what the statics means, coplanar concurrent forces, resultant forces, and the topics here such as centroid and center of gravity, moment of inertia. Again, moment of inertia is classified into two parts. One is area moment of inertia, another part is mass moment of inertia. So these are all topic, and one more topic is known as the friction. These are all topics comes under the part of the statics. The dynamics parts relates to kinetics and kinematics, work energy equation, vibrations. They're all related to functions of time. That's why dynamics. Now here, some terminologies which are very important to understand to do that's a static analysis in engineering mechanics. What is the space? What is the time? The space is nothing but the geometric region occupied by the body. So, but how can we measure? How can we locate? How can we describe that is the geometry of the body, the space, and the body in the space, with the help of linear and angular measurements relative to a particular coordinate system. So if we want to solve the three-dimensional problems, we need three coordinates, and for two-dimensional problems we require a two-coordinate system. So generally in this course, we are strict to solve the problems of two-dimensional. Yeah, another very important term is the time. Time is the measure. What is the time? Is measure of succession of events. So it is a basic quantity of dynamics. Time, all right, the time, and another one is the space. And here, and one more important term, that is the mass. What is the mass? We'll see generally the mass is nothing but a matter of your body. But not only that, mathematically mass also gives is the measure of the inertia of the body. A more mass person, if the person is more mass, means more fat person, he runs in relation, he runs low speed in comparison to the lean person. Why? This mass acts as inertia for running. So that's why, okay, it's a very important term. That's why for a healthy person means having a sufficient mass in the body such a way that he can run faster. That's what. So the person is having a more mass. That means more fat in the body. That's what we call it. The person is less mass, we consider lean. So the person is having a sufficient optimum mass in the body, then we consider a healthy person. So the mass having another, that's why here it is inertia of your body. So what is that inertia means? Resistance to change its position. It can become a velocity or it can become a displacement or anything. That's why This mass works in area mass moment of inertia. That's why mass moment of inertia I equal to mk square. That's for where m is the mass and k for radius of gyration. So that's why mass also affects the gravitational attraction force between it and another between the two bodies. So mass also affects, and also mass is the matter. Generally, we know the mass means the matter of your body, not only matter of your body, and also it is the inertia, measure of inertia of your body. And the mass also helps here. The mass of your body affects the gravitational force as between two bodies. The next term is the particle, and one more thing, we consider the particle when while calculating, while doing static analysis, we consider the whole mass is passing through a particular point. That particular point having, what is the characteristics of particular point? That particular point doesn't have negligible dimension. There is no geometry and also no mass. But we consider that point through which the whole body, whole mass is passing through it. That point is known as the center of gravity of the point of the center of gravity of the particular body. All right. So here, the dimension of the point particle is a negligible dimension near to zero, so that we can analyze it. While analyzing, we consider the mass concentrated at a point. All right, these are the different terminologies. What is a rigid body? We consider the mechanics of rigid bodies. Rigid bodies means when the force is applied on the body, no deformation between. There is no distance. The distance between two particles is zero. That means no deformation. All right, this is what we have studied. And the scalar quantities and vector quantities. Scalar quantities having only one magnitude but no direction, whereas the vector quantities having both magnitude and direction. The force under the category of vector quantity, force, velocity, displacement, acceleration, moment, and momentum, all are quantities related to vectors. These are all vector quantities. So coming to the force equal to mass times acceleration. And suppose we are going to consider the vector quantity velocity v. It is having both magnitude and direction. And here the action of the force having both magnitude and direction, and also the action of the force can be characterized by three things. Number one, magnitude, another one, the direction. The third one is very important by its point of application. Okay, what is the force? Force is the action of one body on another. That's what force is. Action of one body on another body. That is the force. That action is characterized by number one, magnitude, number two, by the direction of its action, and three, by its point of application. All right. This important terminology, the force, is very important vector while doing static analysis or in statics. So coming to the principle of transmissibility of force. Here there are two figures. Here one figure, here the figure 1, and it is figure 2. In figure 1, the force is acting, the line of action of the force having certain magnitude, the direction, the sense, and the direction is F, and A1, A1 and A2. Similarly, here A1 and A2, and in figure 2, and it is the force, the direction is towards the body, and it is in figure 1, the force is acting away from the body. What is the principle of transmissibility of force? The principle of transmissibility of force, it states that the condition of your motion of your body, the condition of your motion of your body remains the same, remains unchanged. If a force is given, or if a force of given magnitude, direction, and sense acts anywhere along the same line of action on the body, on the rigid body. All right, the body is rigid. That is our assumption. In new mechanics, we are going to do it. And the condition of motion of a rigid body is remains the same. That means unchanged. If a force of a given magnitude, direction, and a sense acts, okay, acts anywhere along the line of action of a rigid body, That means, The force F is acting tensile, but it is along the same line of action. But the force F is acting on the body towards the body as a comparative. But the tensile force acting, but the force F in figure 1, F is acting tensile force, but it is acting where? At A2. And the figure 2, F1, F is acting at point A1. So the action, the resultant effect remains the same. Here, in figure 1, the F1 is pulling like that, pulling the body, tensile force. Whereas in figure 2, it is pushing the body. The body moves the same along the line of direction, line of action, same. That's what the transmissibility of force. That is the principle of transmissibility of force. That's what it is acting. All right. Now here, it is very important to know what are the types of forces. Number one, the tensile force. The force acts as tensile force. Number two is the compressive, and the third one is the shear. What is the tensile force? Tensile means is the body here, the cross section of the body. It is the cross section of the body. All right, the cross section of the body. On this cross section of the body, F1, the same one, F1 is acting away from the cross section. Is the tensile. Your force is the body acting. You're pulling in the direction and this direction, going away from the cross section. Is the pulling, means pulling force. This is the tensile force. And another force, yes, if it is acting towards the cross section of the body, F1, here it is also F1, then it is known as what? Compression. What will happen? What is the effect of compressive force? What is the effect of tensile force? The effect of tensile force is it increases the elongation. It increases the length of the body. Deformation takes place. Yes, you may consider it as if the body is a rigid body, no deformation. Yes, but it affects. Suppose the deformation, the tensile force is acting. If more tensile force is acting, elongation of the body takes place and a reduction in cross section will be taken place. What about the compressive force? The effect of compressive force, if you force apply here on the body, it increases the cross section, reduces the length. All right, compression, tensile, yes. And what about the shear force? The shear force is very simple. Due to shear force, if you consider the force, the body is acting here, the cross section. The cross section is the body. What about shear force? The shear force acts parallel to the cross section. The shear force acts parallel in this direction or here, the parallel here, here. This is also parallel. Is also parallel. Any direction here is also parallel. This is a parallel force. Parallel to the cross section of the body, the shearing. Okay, in India, what will happen? The people goes to the temples, they give their hair to the, okay, they will cut their hair. Okay, there is a custom here, punishment, they will take it as a regression. Okay, suppose here the person is having a lot of hair is there. The person who is cutting the hair to remove complete hair, he keeps the blade parallel to the cross section of the hair, shearing. So he keeps a parallel blade of the knife or whatever, and he shaves the head. Suppose you are shaving your head, not only in India, anywhere in the world, the person who is shaving, those shaving of blade is parallel to the cross section of your hair. All right, that means that's why it's called shears. Shears means scissors. Scissors means shear force. Shears means the word is the shears. Scissors come from shears. The blade will be keep. We keep the blade parallel to the cross section of the hair. If you keep the perpendicular to the cross section, what happen? This hair is there perpendicular. You keep. If you shave, what will happen? It will cut your body. So to clean shave, okay, that is called shear force. The parallel to the cross section, you will shave. All right, in that manner. That's why our blades also always, they'll keep parallel to the surface. That's why it cuts. That's what shear force acts. Okay, that's what here the force. Now you can understand the F which is acting at point A2 is the tensile force. The same F which is acting point A1 is the compressive force. Alright, is the compression, pushing. The effect of F is the pushing, whereas the F at A2 is pulling. So, but the resultant effect, final effect is the body moves in which direction? The body moves in the direction of the line of action. Alright. The body moves in this direction. That's what the transmissibility law of force says that. Now let us read it. So it says that what? The condition of your body, the condition of motion of your body is remains unchanged if your force of given magnitude and direction, and one more thing, and sense. This magnitude, direction, and sense, these are all the characteristics of the action of the force. These three acts anywhere but along the line of, along which one? The same line of action on the rigid body. The same line of action is very important to understand. Okay, the principle of law of transmission of force, there are three things are important. The condition of motion of a rigid body remains unchanged. If a force of given magnitude, direction, and sense acts anywhere along the same line of action, the same line of action is very important. This on the rigid body. Then what happens? The condition of motion of a rigid body, the effect remains the same. That's what law of transmissibility of force says. Another thing is that not only body, the person is having, is the person, you can see it, is the ear, this is the ear, and also it is also here. If the person is pushing the head and another person is pulling the head, the F acts, the pulling, the ear. And here the person is same for the same person, but along the same line of action should be there. The force magnitude should be same. What are the two things should be same? One is the direction, the magnitude and direction, and the same sense of point of action. But these two should be same, and also one more thing, it should act along the same line of action on the rigid body. It should be same. Then what will happen? Yes, what will happen? The effect remains, the condition of the motion of your body remains the same. It doesn't be changed. It remains, it won't be unchanged. It remains unchanged. It means it remains the same. That is the what law of transmissibility of force says. Alright. The next one you can understand so many ways. So why it is required, this concept? This concept is required even though the force, the type of force may be tensile or compressive. We can make it that the effect remains the same by using this law of transmissibility of force. And the next one, coming to the picture of, in this figure, we can understand here the mg, the acceleration, the gravitational force, the mass of your body is m, with the pulling upwards, pulling direction, and the gravitational force mg. And one more thing, here we applied by using the transmissibility of the force. If the pulling effect remains the same as a pushing F, the pushing upward direction. The direction is upwards, whatever here it is, see, it is along the line of action. But one thing, the force always acts for downwards, which is that the weight of the body due to gravity, it always acts downwards. So it is acting here downwards. So what is the total force? Because of the part pulling or pushing is the F1. But if it is hanging to some rope, there will be a tensile force. That there will be a tension. That tension is the T1. and mg, the gravitational force weight, and it is the F1 is pushing or pull one. Then what is the total tensile force? By that considering the mg force, then what will happen? This T1 plus F1 is the total F force, resultant force acting in which direction? Upward. But if we consider the weight of the body, the resultant force F equal to T1 plus F1 minus mg, because the direction of the weight is acting downwards, the pushing or pulling acting upwards, and also tension, the tension force, the tensile force is also upwards. So here why we consider this figure, why we got it, because here a rigid body having a mass is being lifted with an acceleration by a means of force acting at different places along the same line of action, passing through, very important, centroid or center of gravity. That's what, passing through the center of gravity C. Now that is what shown in figure. Now a string with a tension T, because of that string is having a tension pulling it up, or acting upward force applied from below, or a combination of such that is that the resultant force F equal to tensile force T1, which is in tension force, plus the pushing force which are giving F. The pushing force F1. Now what is the pushing force here? That F1 equal to here, total force equal to T1 plus F1. Now if we consider the weight of the body, that means what? T1 plus F1 minus mg, the total force. Okay. Now if we want to do this total resultant force or the total force, we have to go for free body diagram. What is the free body diagram? Okay, the free body diagram is nothing but we have to remove the supports and draw the diagram with the reaction forces. That diagram is known as the free body diagram. What is the free body diagram? Free means removing all supports, all covers. Then with the reactions, we have to draw the diagram. That diagram is known as free body diagram. Here the figure 1 and figure 2. This figure 2 is known as the free body diagram of a main diagram. This is the diagram having a mass m. The weight of the mass is m, and having a weight SW, and which is supported on the floor. And remove the support. If we remove the support, in the place of the support, we have to do one reaction. That reaction acts vertically upwards, passing through the center of gravity of the body. So this is what center of gravity of the body is passing through. Reaction 1. This R is acting upwards. The weight due to gravity, that the weight is acting downwards. But these two are along the line of action. Yes, it should be along the line of action. This figure 2 is known as the free body. Alright. Now pause. If we consider there is a cylinder or sphere on the surface, on the floor. The weight of a sphere is W. Now how to do the free body diagram? The free body diagram, the circle, the weight of the sphere acts downwards. What about reaction force? This is the reaction force which acts upwards, passing through the center of gravity of the body of the sphere. That is the reaction R. What is the resultant? What is the total reaction force? What is the total force? That F equal to, okay, the R is acting upwards and the weight is acting downwards. R minus W. Alright. So provided the reaction force is considered is more than the weight of the body here. In this case, you may consider R equal to W. Alright. It will be nullified. That is a different. That is the total force. Now, this here the concept is that the free body diagram. Next, if you consider next case, you understand better. Suppose there is a wall is hanged. Consider here. Here, this is a wall. Here, this is a string. Whatever here, it is the string, and it is the sphere. A sphere is supported with the string and also supported by the wall. How to draw the free body diagram? And this sphere is having a weight W. The sphere is having a weight W. How to draw the reaction? How to draw the free body diagram? Free body diagram is short from FBD. The free body diagram, first draw the sphere, the main, and there is a reaction acting in this direction, and also weight acts downwards and the tension acts to T. Now, this tensile force is having some inclination theta. Now, draw the point. This is theta. Alright, through this theta, the reaction is R. Whatever the weight acts downwards to the tension T. This diagram is known as the free body diagram. Free body diagram consists of reaction forces and action forces, but no supports. Free body diagram means free of supports. That diagram, that body is known as with reaction forces, is known as the free body diagram. Alright? Did you understand? Okay, one more thing. Shall we consider some more cases to understand better this free body diagram? Alright? These are the supports having inclination theta. This is ball 1, 2 and 3. How to draw the free body diagram? You may consider another support also. Okay, this is also another support. 1, 2, 3. How to draw the free body diagram? Please practice how to draw the free body diagram. Let us start. Now there are 3 balls are there. The ball 1, ball 2 and ball 3. So ball 1 is having how many supports here? 1 here, another one, this direction, there are 3. And along with that, from these 3 supports, reactions will come, acts on that body, sphere 1. So I am considering the sphere 1, this inclination, you have to understand that inclination, but passing through the point. That is, here we are considering 1. There's 1 reaction and another reaction from 3 ball. That is another reaction. I am considering as R3 on 1. There is another reaction is there. So with some inclination should pass through R2, 1. There are 3 reactions which is acting. One reaction R from support, another one is from ball 3, from sphere 3, and another reaction from sphere 2. Now, here, these are the reactions. This ball 1 also acting action, but we are considering reaction. Along with that, the weight of the ball, W1, acts downwards. This diagram is known as a free body diagram of which ball? Sphere 1, ball 1. Similarly, the free body diagram of ball 3, you can practice, yes, and ball 2. How many reactions will come? There are 2 reactions on ball 3. That is a reaction that R31, okay, R31 and R23 and R13, and also weight. There are three forces. Similarly, how many forces on the ball 2? This direction 1, 2, 3 and weight reaction 4, contact surface and also reaction 5. 1, 2, 3 weight 4 and others reaction by horizontal support. Total 5 forces acts, reaction forces and action forces comes to the sphere 2 or ball 2. All right. So ball 1, ball 2 and ball 2 and ball 3. So in this manner, we have to draw the free body diagram for what? Calculating the reaction forces with the help of various theorems. One of the theorem is Lami's theorem. All right. So in this manner, we'll calculate the unknown reaction forces with the help of the action forces, like that in statics, while for doing static analysis. Okay, let me summarize in this session what we have studied. In this session, we have studied what are the terminologies of engine mechanics, and also the principle of transmissibility of the force and free body diagram. In the coming session also, we'll focus more on free body diagrams of various cases with more case study, because this free body diagram, once you have drawn the free body diagram with some both, what are the three characteristics are required here? We have to consider the action of the force, the characteristics of the action of the force. First, magnitude, first characteristic. Second characteristic, direction. Third characteristic, sense or point of application. These three are important. These are what is the value? Magnitude and direction. With what inclination? Direction, both horizontal and vertical. And third one is the point, where it is. These three, with those three characteristics are required to find out the unknown reaction forces. All right. Suppose, yeah, those three characteristics are required to find out the external forces. That's what our main aim is. That's what here, with some inclination, theta mentioned here. What the theta affects here, whatever reaction force. So similarly, with some what angle, this reaction force is acting on body 2, and the weight is acting downwards, W2. Here also W3. And what about reaction from ball 1, reaction from ball 2 and ball 3? And what about reaction of the ball 3 on ball 1? And here the Newton's third law come into the picture. Whatever the ball, the reaction coming from R1 is acting on 3, and same equal reaction acts ball 3 on ball 1. So R13 equal to R31, equal and opposite. Similarly, R3 is acting R2. That means R23 equal to R32. So by using Newton's third law and the characteristics of the action of the force, we have to draw the free body diagram. Then we will find out the reaction force of R31, R21. Okay, that's what we have studied. And we are going to study in the coming sections also with more free body diagrams. That practice is more important to find out the reaction forces. All right, thank you.
Like, share and subscribe. Hit the bell icon for more updates.